A teacher wants to divide his 20 students into 5 groups for a project. Groups can contain any number of students, but they cannot be empty. In how many ways can this be done? Well, the answer is given by the Stirling number of the second kind, denoted as shown. In general, nk counts the number of ways to partition a set of n objects into k non-empty subsets. For example, nn is equal to 1 for any positive integer n, since placing each object in its own set is the only way to distribute the n objects among the n sets without leaving one or more of them empty. And these sets themselves are not ordered or labeled, they are only defined by what's in them. For another example, it is easy to see that n1 is again equal to 1. The Stirling number of the second kind follows a neat recurrence relation. To find n plus 1 k, we can think of first setting object n plus 1 aside and distributing the remaining n objects among the k sets. So far, this results in nk different configurations. For each one of these configurations, we can place object n plus 1 into any one of the k sets, resulting in k times nk valid configurations. However, since by definition all of these sets had to be non-empty before adding the object n plus 1, this does not account for the configurations where object n plus 1 is in a set of its own. In that case, since one set would already be occupied by object n plus 1, we would be counting the ways to distribute the remaining n objects among k minus 1 sets. Hence we obtain the recurrence relation n plus 1k is equal to n k minus 1 plus k times nk. Follow for more combinatorics.